Hello, it's Steve. I was just sitting down to set up my next prototype project when I thought, hang on a minute, most of this stuff is just going to carry over from my last few projects. Then I thought, well, maybe it would be useful to someone else. And then I wrote this script, and then I found out that you can just pack a scene and boom, it's wonderful. But I had to rethink my entire architecture. So here it is. Steve's Godot game architecture version 0.2.1. This isn't necessarily a recommendation so much as, hey, here's my interesting approach. Hope you can pull something cool from it. All right, let's go. I'm in a project here where all I've done so far is set up the viewport to the GBA pixels and added some folders. For more information on the viewport and other visual things, check out this video where I went over how I like to do the visual side of my prototypes. But that's not for this video. This video we're talking about the architecture code and the scenes and things like that. First off, we'll make a main scene with a root script. Other than Godot freaking out on me, something like that. The reason I like to call this first scene main is that it basically serves as a main function for the rest of the project. It serves as a bootstrapping layer and outer shell for the actual game. This also gives us a place to manage our own singletons, which I prefer over Godot's built-in auto-load singletons. We'll start by adding one of those singletons now. I'll add a scene manager. And here's that code. Don't mind the commented out things for now. We'll get to those in a minute. But really, the core of it is just a basic scene manager that replaces whatever's under the scene root with whatever we have to load for our next scene. There are plenty of tutorials and resources out there for making way more useful and complex versions than this. And the way I'll do this will likely change when I figure out some standard way to do loading screens if I ever need that. Why use this scene manager at all? And you know, that really ties into the main scene too. The default way the internet seems to talk about changing scenes in Godot is just to replace the root node. However, that requires having code like this all over your project, and I much prefer that. There's our main scene out of the way. Let's get into the main menu. I like menus even in prototype games because a simple menu is really easy to make, so it doesn't increase complexity like at all, and it gives us a place to put debug functionality like loading and saving. For now, just a quick title and a start button will do, and we'll make sure our game is set up to load the main menu when ready. And of course, not forget to actually include the main menu in our scene manager. When I launch this, I'll go ahead and set the main scene as the main, and we have a menu. Next up, the game scene. For now, we'll just make an empty scene called game, and we'll add it to our scene manager. And then in order to load up the game, we'll go ahead and bind the pressed action of our button. Oops. We forgot to add a main menu script, so I'll go ahead and do that too. And in there, we'll just once again call our scene manager. If you're wondering why I do scene ID like this, rather than just passing in whatever reference to the scene I want to load, Godot has a weird thing with loading back around to previous scenes in this way. It's because whatever scene you're loading up end up having a reference to your initial scene, and there's some sort of circular reference check that triggers that causes it to explode, basically. Instead of that, I just decouple it using an enum and an array, and it works just fine. All right, we'll launch one more time, and there we go. When you click on the start button, it goes into the game scene. You can tell because the main menu goes away. Now, we're finally moving away from scene management. Since this video isn't about the actual design of a game, here's a simple player controller that can move using the arrow keys and also listens for space to increment its experience points. Very, very top of the line player controller here. Let's not forget to actually add some visual data to the player so we can tell where it is. There's something exploding. What's exploding? I added those inputs to the input map, and when you move around, you move very slowly, and when you press space, you get some numbers going up. Very cool. Very, very engaging gameplay, truly. I'm actually even going to go in here and increase the movement speed by a bit because that was terrible. This is just here to demonstrate a game state approach. This is one way to do it if you only have one little guy you got to deal with, but I don't tend to like to have game state relevant variables directly on my nodes. Let's talk about how I like to handle game state. I used to save all game relevant info into a big statically available game state object. You can think of this like a database that I could serialize and deserialize for saving and loading. And this meant that our traditional game entities, think like the player, function more as glue code that reflected the state of our game to the scene itself. And that worked okay, but it meant duplicating a lot of out-of-the-box engine things, like even position, and that meant reinventing the wheel a lot, like for collisions and things like that. Luckily, I figured out how to use packed scene recently, and that has upended that entire thing and made it a whole lot easier on me. I'm still using a large statically available game state that we'll get to in a second, but I no longer have to serialize and deserialize manually or duplicate game engine properties just because those are automatically saved with the scene while it's packing. So let's get into that. In our data, we'll add a new folder for state, and to that we'll add a game state script, extending resource. And just so I can demonstrate this, I'm also going to add a player state script, also extending a resource. So let me talk through this a little bit. Basically what we have here is two different resource classes, the game state, which references our player state, but would also have references to a whole bunch of other things. This is the root of our state object. And then the player state itself, which right now only cares about experience, but might care about attributes, health, stuff like that. Things that players tend to care about. And since these are resources and they're exporting their variables, that means when we save our scene, the resources themselves will be saved in there. And I'll show you that in a little bit. So getting a little bit more into it, how do we actually get these into the game itself? We're going to add a game state manager to our game. So this is the game state manager. As you can see, a really simple class. Its only role is to maintain our game state object and allow it to be saved and loaded alongside our scene, as well as surfacing a singleton of that game state to whatever needs it in the project. So let's go ahead and update our player to use this instead of an experience here. One pattern I like to follow is adding a state reference right here. If we had say signals, we could actually connect to signals on here too, but we don't have any right now. But we could get updated.connect to whatever. We don't really care about that particular part right now. You can probably see how that would work. This means that we can store that experience and whatever other attributes we might want, health, whatever, on that state object. And then other classes can reference that easily without needing a reference to the player. And that's more handy than you might think. All right, so why do this at all? Why would we separate the data and logic in this case? Well, my favorite example to use is collision. So say you're building some sort of platformer and you want your player controller to collide with enemies and get hurt or, die or whatever. Where does that collision logic live? Does that live in the player? I mean, that would be a good enough place for it, right? Because, the player's the one that's going to be dying. Does it live in the enemy? That's actually not too bad of a place for it either, because you might be able to judge how much damage the enemy does or something like that. It probably lives in a collision manager of some sort that tracks these collisions, right? Well, in any case, that's a lot of philosophizing about who owns what data, when really the data is just data. It doesn't need to be owned by anything, although this is very much an ownership pattern where the player is basically the primary owner of anything under player state. In practice, multiple things could own player state, right? You could have a health controller completely disconnected from the player that reacts to health updates, things like that. And really, you don't even need to have the experience tracking in the player at all. Experience can be a separate concept from the player, and the player controller can pretty much just focus on movement, which, if you've ever made a game before, is usually more complicated than this and deserves, in my opinion, to have its own full file dedicated to it. But I'm getting into the weeds. One small change here. I used to use this pattern when game state was loaded outside of the game scene, so I could always be confident that this existed. But since that's no longer the case, and Game State Manager exists as a node inside of the game, all you really need to do is throw that up to the top of game so that it readies first, and then we can continue going on using this pattern, which is, I think, pretty handy. I mean, really, this is only useful for players. For enemies and stuff, that state will usually be assigned externally while the enemy is spawning. So let's actually get to saving and loading here. I'm just going to add a very simple saving and loading system so that we can just check that it works. To get that working, I'm just going to add a little way to get back and forth between the game scene and the main scene. And we'll get right to adding a save game manager. Now let's talk about what we're doing here in this save game manager. First, there's a little flag just for debugging. So if I wanted to like restart a new save file while I'm testing, I can flip that flag manually. There's also a save path and the default game scene to initialize if we don't actually have a current save. And then there's just two basic static functions on here. The save creates a new packed scene, packs the current game scene, and then uses resourcesaver.save to save it to our path. This is how you actually save these scenes. And how do you get that current scene? Well, anytime you load up through the save manager, it sets the current scene to either a new game default scene or whatever it was able to load using a resource loader.load on the save path. That should be all we really need other than actually calling those saves and loads. So let's jump around to a couple of places. First of all, the game should probably save when the game actually exits back out to the main menu. That's where we'll save for this demo. And then going back to our scene manager, this is where this little commented out chunk of code comes in here, where we'd have a little override for if we're loading the game scene, then we'll try to load a new scene, which again, will grab the default game scene if needed. With that, this should be saving and loading. Let's see. And of course, I had a save file out here from when I was originally working on this, which had a slight difference in implementation that was causing everything to explode. Yay! Okay, well, with that gone, let's try this again. All right, we're loading up. Spacebar increments our counter. I can hit escape and start again, and look, it's still here. And just to prove it, we'll close the entire app and restart. Hey, it's still there, and the counter is still approximately where it needed to be. It was approximate because I forgot to back out to the main menu to save. There's saving sorted up. I guess I'll show off. This is what the save scene ends up looking like. As you can tell, it's just a scene. The resources get loaded in through these sub-resources guys, which will end up saving all of the data of our game. I'm sure there's some pitfalls of this that I haven't run into yet. This is kind of new for me, so I'll probably end up posting something at some point, like a follow-up to this video after I use this method in some more prototypes. Anyway, so there's saving and loading out of the way. One final little thing to do that I like to do in every project is to add a little config folder in here and to create a game config class. You could split this out into a handful of different classes, but I like to keep as few files as possible because the whole point of this is to be able to go to one place to edit your configurations and balance. Say I want to increase our experience per spacebar pressed, I can do it here. And now all I need to do in the player is reference this, and there we go, it still works. I've also increased the amount of experience per spacebar press, as you can see. Nice. I personally like have the configurations in here. It's a whole lot nicer than having them like in some scene somewhere, like having to go in and update anything over here blows, in my opinion. I believe that's it. Anyway, hopefully you found some cool ideas in this video that might inform your future projects. Did you know that scene packing was a thing? Am I just late on that particular boat? I swear I must have Googled that functionality like 20 times over the years, but I never found it until now. Let me know in the comments. Later.